Hello everyone, I welcome back you all again. Myself Chitra Shriyam, student of Sri Venkateswara College of Engineering from first semester audit section from the Department of Computer Science and Engineering. In this video, I will be discussing about the topic ordinary differential equation of higher order. Let's know the contents of my presentation. Initially, the definition of ordinary differential equation, types of ordinary differential equation, formulation of higher order equations, analytical solving techniques, and the steps involved while solving those equations, second order ordinary differential equation, and an example for it, and finally the summary. Let's know the brief definition of ordinary differential equation. They are the equation that relate a function of one independent variable to its derivatives. Higher order ordinary differential equations involves derivatives beyond the first order. In other words, the highest derivative present in the equation is greater than 1. Moving on further, an ordinary differential equation of order n is of the form of equation in the below mentioned manner, where x is the independent variable, y is the unknown function of x, y dash, y double dash, so on, y power n are the first, second, till the nth derivative of y with respect to x, and f is a function of x, y, and its derivative. Frequently, I am using the term order, which means the highest power of derivative present in the equation. When it comes to the types of ordinary differential equation, there are mainly two types. Initially, the first order ordinary differential equation and the higher order ordinary differential equation. When it comes to the first order equations, the highest derivative of the function of independent variable is only 1. And when it comes to the higher order ordinary differential equation, they contain at least a second derivative of the function y. Formulation of higher order ordinary differential equation. There are some general equations of ordinary differential equations which are classified based on its order. For example, for first order, the general equation is of the form dy by dx plus p into y equals q, where p and q are the functions of y and dy by dx is the derivative of y with respect to x. And for second order, the general equation is d square y by dx square plus ny into dy by dx minus m into y power 2 equals p, where m and n are constants and d square y by dx square is the second derivative of y with respect to x. And it continues till the nth order. The general equations for nth order is d power n into y by d into x power n plus p into y into d power n minus 1 into y by d into x power n minus 1 plus q into y power 2 into d power n minus 2 into y divided by d into x power n minus 2 plus, and it continues till the k into y power n, and this equation is equal to 1. Analytical solving of ordinary differential equation. Solving of higher order ordinary differential equation can be more challenging than solving first order equations, but there are some several techniques available such as homogeneous and non-homogeneous equations. In this, separating the variable into homogeneous and non-homogeneous parts and solving them separately. And the next is characteristic equation, finding the roots of characteristic equation to determine the general solution of the homogeneous equation. And the last, undetermined coefficients or and variable of parameters, finding particular solution of the non-homogeneous equation using some other techniques. Steps in solving ordinary differential equations. It mainly involves two steps. One is the separation of variables and the other is the integrating factor. The separation of variables is done when the given differential equation is given in the form of dy by dx equals f of y into g of x by rewriting it as 1 by f of y into dy equals g of x into dx, where f is the function of y only and the g is the function of x. Integrating factor technique is used when the given differential equation is of the form dy by dx plus P of x into y equals q of x, where P and q are both the functions of x only. As our topic is higher order ordinary differential equation, let's mainly concentrate about second order ordinary differential equation. It includes second derivative of the function. There are mainly two types. One is the linear second order ordinary differential equation and the non-linear second order ordinary differential equation. An example for second order ordinary differential equation. The given question is d square y by dx square plus dy by dx minus 6y equals 0. For easy purpose of calculation, let's consider y equals e power rx. So by differentiating the y, we get dy by dx equals r into e power x. By the double differentiation, we get d square y by dx square equals r square into e power rx. By substituting these derivatives in the given question, we get the equation as r square into e power rx plus r into e power rx minus 6 into e power rx equals 0. In these three terms, we are having the common term as e power rx. By taking it out, we get the equation in a simplified ordinary quadratic equation manner as e power rx into r square plus r minus 6 equals 0. By using the factorization method, we will get the two values of r, that is r equals either 2 or r equals minus 3. So initially, we considered y equals e power rx. In the place of r, let's substitute once 2 and once minus 3. So we get y equals e power 2x and y equals e power minus 3x. We know that the general form of ordinary differential equation, especially for the second order, is of the form y equals a into e power ax plus b into e power ax. So finally, we get the answer as y equals a into e power 2x plus b into e power minus 3x. Let's know the summary of ordinary differential equation. In differential equation, the complete set of solution is usually formed by the general solution, which includes the linear combination of particular solution. We can reduce the complex form of the equations into simple quadratic-like equations. Thank you for watching my video. Please do like, share and subscribe.